I'm going to put a marker into Twitch. Start. Cool. So as long as my internet connection doesn't go down, which would obviously affect the entire meetup, then I'm going to be able to just straight up export this out to YouTube right at the end. So free recording. All right. So let's see. One of the things we wanted to talk about was, where is it? Here it is. Microsoft Azure Functions. There is a vote in here, and I'm going to share this out with Twitch chat as well. So I believe if you have just a Microsoft account, or does it have to be like a Microsoft Azure account? Do you know?
Not sure.
Yeah, I don't know like what account you need for it, but there's a vote here to attempt to convince the Microsoft Azure team to basically add, it looks like, Rust as a first-class citizen for their version of Lambda functions, which would allow us to write Rust little microservices essentially and deploy them out and just have them in the cloud and run them, which would be amazing because running Rust in AWS is not fun. And I think we had I'll share this link out with Slack chat as well, because I think it's been...
By the way, is there a Slack channel that you guys use?
Yes. Are you in Denver?
No, I'm actually in North Carolina.
North Carolina. So, because this is the Denver Rust meetup, there's a community called Denver Devs, right. And that's how we organize this. And there's a Slack team for Denver Devs. If you just Google for that, okay. you will find it, and you can like add yourself and be Denverite in name only. There's like 5,000 of us in there now. It's a pretty amazing community. Outside of that, I don't necessarily have anything. I've been creating my own Discord team just like for my own stuff. I suppose that we could do like some collaboration around there. And then Rustation Station, that's the Discord for the podcast and also the This Week in Rust newsletter. That's also an excellent place to sort of gather.
Yeah, I did get the link for Denver Devs, so I will join that.
Awesome. Well, it'll be great to have you there, even if you're not here physically. If you ever come and visit, we'd be happy to meet you whenever that's possible again.
Sure.
All right. Other things that are on Rust type stuff. Somebody was asking how to get started with Rust. If you go to rust-lang.org, this is like the perfect place to just get started. In fact, if you just go to learn off of this, there is the book. Whenever any of us would say like, oh, read the book, this is the book. Oh, thank you, Dan, for those links.
Yes, perfect.
The book is always kept up to date. It's also the same book that you can buy on what I think it's called I forgot what it is.
Like the No Starch Press book, right?
Yeah, it's the same as the No Starch Press book. Yeah, that's exactly right. There's also the wrestling course and Rust by Example, which I think each one is like slightly more advanced than the previous. So like if you've read the book, the wrestling's course might be the next best thing to do, and then once you've done that, the Rust by example is sort of like just here's like code and how it looks. But knowing a little bit about Rust would probably help going through any of those resources. And another question, does the Mozilla Foundation provide the development resources for Rust? It did before. So a brief history of Rust. Mozilla, it started at Mozilla. It was a side project, an official side project. And then Mozilla decided that it was, actually going to go someplace. So they brought it in full time and like provided a core group of people and paid them to work on Rust. It then took off. They started rebuilding Firefox in Rust. That's where Quantum actually was like a portion of the browser was rewritten in Rust, which is actually a lot of their speed increases was due to Rust itself. And but I would say nowadays Mozilla doesn't really provide very much, especially after the layoffs. They're not really doing. They don't need to do much for Rust. It's become its own thing.
So are there networking libraries in Rust? Does Rust provide a way to access the OS's network stack libraries?
Absolutely. So I would like to describe Rust as a multi-purpose programming language. It's not like specific. It's not built to solve any one problem, but really it's meant to be able to program generically across any type of problem. So I would also put JavaScript after Node.js came around, Python, Go, any like Java, C, C++, all those languages fall into the same sort of generic programming language category, which is you can build anything you want in the language, and it works really well. Are you familiar with Node.js and npm?
Yes.
So there is crates.io. I'm showing this on the screen right now. This is the Rust equivalent of npm. It is the official package repository, and you can come down here and search for categories, and network programming is one of the popular ones. And basically, like, you create HTTP libraries. I think there's also I know that there are libraries for actually just doing straight to the networking stack itself.
Right.
But because this is just like npm, anybody can upload or upload any of the their crates, as we call them, to crates.io. So
yeah, so I think that the like raw TCP networking is in the standard library. It's stdnet, I believe, right?
yeah, so this is like just accessing it.
Right. Right.
So the answer is yes, you can. How painful that will be depending upon what library or module you end up using.
Right.
Because Rust is a newer language, it's actually there's less crates out there that are like super nicely written than something like Node.js, where in Node.js you have a billion different npm choices, some of them amazingly good for accessing, sockets or
Yeah.
what is the GDP? I forgot the RPC.
gRPC.
gRPC. Like, I know there's one for
gRPC.
Rust, but I don't know how good it is. Oh, and Dan Shields just posted a link to the Rust main Discord. That's awesome. All right. Any other? Does anybody have any announcements that you'd like to make before we officially get started with the talk? All right. Well, with that, let's go ahead and get started. So, I started it by naming it something completely different, but the general idea was the same, and then I realized that the name might have been slightly confusing, so I changed it to Learn Rust by Making a CLI to Do Application. I decided to do this because every single front-end framework out there always starts off by saying, hey, let's make a to-do app. And it's always that sort of silly introduction tutorial that shows you how to do the two-way binding and all that stuff. And I figured, it'd be fun. Let's just do the same thing here with Rust. It's a familiar problem. It's pretty easy to get into. It doesn't go too deep into the language, but deep enough to sort of lean into it a little bit and decide if you want to continue leaning in. But first, who am I? So I'm Brooks Patton. I'm a lead developer at a company called Health Scholars. We don't do Rust. As much as I would love to introduce it to my team. I do web development with PHP and Vue.js. We also have a Unity team that's making all sorts of VR type stuff, but I'm not on that team. But I also live stream myself every single weekday morning, except when I'm on crunch time at work, which is unfortunately right now, and I'm exploring a lot of Rust during that time. So I've been building some games with Rust. Also on Fridays, been exploring WebAssembly, and on Sundays I've been creating a tutorial series in Rust for just getting started. And I've also been working in the IT industry for a bunch of time. I first learned C way back in the day when I was a systems administrator at NASA, and just sort of forgot all about that until more recently, when I decided to get into what first turned out to be systems languages, but it's kind of not really a systems language anymore. But I'll get to that in a second. So the objectives for this talk, I want to inspire you to learn and create something in Rust, or at least to decide if you want to go into Rust. So what is Rust? As I mentioned before, it's a general purpose programming language. You can do anything you want with it. How difficult that is sometimes things are more difficult to do in C than maybe Python. Sometimes things are more difficult in Python than C. Rust will fall into that area, and the more proficient you get with it, the easier those problems get. So if you use Rust and it's hard for you, it may not be that it's not right for the problem. It just may be that you don't know really good solutions for how to do it in Rust yet. Something that I have noticed is there's often a solution, but if you don't know how to do it easily in Rust, it can be really hard to sort of do this big, huge workaround to make it work. That's actually one of the reasons why I have here is great community is a really big necessity in Rust. The documentation is good if you know exactly what you're looking for. If you don't know what you're looking for, you may not know that it exists. And so asking somebody is really a big deal here. It's no longer built as a systems programming language. So if I come over to the Rust lang, where did I put that? It's right here. The Rust website used to call itself a systems programming language, and I think it was Steve Klabnik, but I don't know if that was who had said for sure. He defined a system programming language as a language that's really focused on running as fast as possible. So basically compiling away all the abstractions, making it run like super, super, super fast once it's compiled. But they decided that the word system programming language was actually causing some people to opt out and like not even start learning Rust because that just seems so hard to get into. I can't do systems programming language. That's like kernel developers, but Rust is so much more. It can do so much more. And so you notice that that's been removed. That being said, I feel I need to mention that because there's so many blogs out there that do talk about it because at one point in time, it was built in that way. The type system in Rust is super strong, much stronger than something like TypeScript. I would even argue that it's stronger than Java or C++. And because that type, the strongly typed nature of it, you'll fight it. You'll fight the compiler a lot, but also the error messages are amazing. It'll always tell you exactly what's wrong and won't compile unless it actually will work. And modern tools. So the tooling in Rust is modern because it's a modern language. They don't have 20 years of language to sort of like work around and have to work with backwards compatibility. They're able to take the best of everything and sort of put it together. I would say it's very similar to, in that way, to like C#. When that came out, it was taking the best of all the different languages and putting them together to make a new one. I would argue that that's the same thing that's happened here in Rust. And we can see that in how we program with VS Code. There's language features that are just so nice to work with and don't have to fight against the compiler itself. And one last thing that I learned very, very recently, Rust is one of the few languages that actually, like the language itself, has a code of conduct with it. So if you want to contribute to the language or be part of the community, you have to agree to that code of conduct, which I think really helps in making sure that the community is super, super awesome. To date, there's only one incident of super negativity that happened in a Rust community, and that's around the ActX X web debacle. I don't think any other big negative events have happened in the entire history of Rust, which is around 5 years or so. So, why Rust? I would say it's fun to use. That your mileage will vary with that. I personally feel that Rust is a great anti-burnout language. It's hard. It's like solving hard problems, but it's not like spinning your wheels and doing things without knowing why they're not working. Rust will always tell you why they're not working. Rust is, as I mentioned, capable of doing almost everything, and I think that having like all of that modern tooling, like testing is built in, documentation is built in, all that stuff is super, super awesome and lovely to have in a language. A question I have is, what was the event? ActX Web, the original creator of ActX Web made the web server in order to beat all of the speed metric tests and be the fastest out there. He used a lot of unsafe in his code, and it then blew up and became this huge web server that a lot of companies wanted to use. A lot of Rust developers sort of became very negative and hostile when confronting him about the use of unsafe. And I think that it could have been brought up in a much more pleasant way and much more political way. But instead, it got so negative that the maintainer essentially quit and left. I don't even know if he's like doing Rust development anymore. And AccessWeb is still being developed. Version 3.0 just came out like a couple weeks ago. And all the REST stuff has, all the unsafe stuff has, well, a lot of it's been removed, and it's still as fast as it was before. It could have been resolved much nicer, but that's the only event that I know of that was like very negative. And I'm hoping that we can all like not have that in the future. Okay, so the project. I don't know how long this is going to take me to make. I'm going to try to make it as simple as possible. And if any of you have any questions, please feel free to either ask in like the various chats or just interrupt me if you're on Zoom, and I'll be happy to answer them. And I'll try to explain what's going on as I program these. So what I'm going to do is I'm just going to add in. I want to be able to see a bunch of tasks, add a new task, mark the task as completed, and delete a task. So I'm going to move this to my other window. And let's go ahead and get going. So off of the main REST website, to install REST, you install something called RESTup. This is like NVM, Node Version Manager, or RVM if you're used to Ruby Version Manager. It handles all the different versions of REST. So you can have multiple of them on your computer at the same time. I just updated here, and I have the latest version. So I'm going to do cargo is how we do everything with REST. I'm going to create a new binary application, and I'm going to call this to-do app. I'm going to cd into to-do app, and I'm going to open up VS Code here. And apparently download the new version of Rust Analyzer. So there's a few VS Code extensions that make Rust really nice to work with. Rust Analyzer is one of them. Rust is the other one. Either of them work really well. I like this one. And crates is really nice. This will actually work with crates.io for you and sort of like show which ones are available, like what the latest version is. And that's pretty much it. If we take a look here, this is, can everybody see, is the text big enough for this?
Yes.
Yeah.
Yes.
Perfect. One question, why not just using rustc to avoid being distracted with project stuff? Rustc, like, cargo gives you everything you need and like does all the linking for you, and especially if you want to bring in other libraries. I don't know anybody that just uses rustc on their own except when you start doing embedded stuff. So generally, you never use rustc on its own. You let cargo run that for you behind the scenes. So every time you create a new Rust program, it starts you off with a hello world. I'm going to open up our terminal here and just do cargo run. This is going to compile it and execute it at the same time. And here is our hello world. By running that, we also get this target folder and inside debug. And here is my to-do app exe. So that's where that is. If I want to run this in release mode, it's just same cargo run -- release. It compiles it with all of the optimizations set in, and it removes all the debug, everything that would like help you know what's going wrong with your program, and then executes that. This is pretty fast compile time right now, but I have seen multiple minute compile times when with a big enough project. So compile times in Rust are painful with real world projects. But the reason why it's painful is because they're trying to do a lot of protection stuff at compile time as opposed to, at runtime. So our first task is we want to see all of our tasks. So what I'm thinking of doing is just having a infinite loop. We're going to run this, and it's going to ask us like, hey, what is what do you want to do? Like, show us all of your tasks. So I'm going to start by creating a place to store all of these tasks. I'm also going to put this all in the main the main program here. So I'm going to start by, let's create a vector. If you're used to JavaScript, this would be like an array. There are also arrays in Rust, so it's a little bit interesting. Think of vectors as JavaScript arrays, Python lists, C++ vectors. What other language? I'm not sure what's the other language data structures that are like them.
Java's array list.
Array list, yeah. It's basically growable, so we can change it and like add to it. List on Java, right? Okay. So I'm going to create this as our to-dos, or maybe we'll call them tasks, equals a new vector. I have to give it a type in here. And so I do that, actually, I'm going to do a vec new, like that, and that instantiates a new vector. Rust is a semicolon-ended language, so we have to add this in. This sort of colon type in here, I can't actually select it. This is being injected by Rust Analyzer for me, so it's showing me what this type is, which is one of the reasons I really like it. And you can see that it doesn't know what the type is, so it's going to try to figure out what it is once I start using it. Well, I want to like be able to add in what a task is, and I'm thinking a task should probably have a little bit of data associated with it. So let's create a like a data structure that is a task. So down here, I'm going to create a struct. There are no classes in Rust. The closest thing that we have to them is this struct. I know that C# has a struct as well as a class, so I guess this is like it's the equivalent to that. And so Rust is not object oriented, but you can almost get there through some tricks. So I'm going to create a struct task, and we're going to basically give a blueprint for what this is going to look like. So this is very similar to what a class would be. We want the maybe name of the task, and I'm going to say that this holds a string. We want to know if it's completed or not, and I'm going to say this is a Boolean. And maybe that's like the only things I really care that this has. And so now I can say that tasks, I can tell it that this will be a type, vec task here. And so I can manually say that that type is going to be there. Or I could just start throwing things in. So I can say task.push, take this task and give it a name, and I don't know, give a meetup talk. And completed, let's say this is false. Well, first problem here. So this is actually one of the biggest pain points when you first start learning Rust, is there are multiple types of strings. One would think that me giving double quote and writing this in, it's a string, right? The problem is it's actually a static stir. So I call it stir because I need to differentiate between STRs and strings with a capital S. If you go and look at the source code for Rust, which is, by the way, written in Rust, a string is actually a struct that wraps around, like that's just a vector of stirs. So there's this big entire thing about like where in memory it lives, and you can actually control that depending upon what you end up using. That being said, if I want to convert this into a string as opposed to a stir, I need to do something like string from, and there we go. This now is a full string. Now I have another error message coming in. It's telling me I can't borrow tasks as mutable because it's not declared as mutable. Rust by default, everything is immutable. So it's saying like, I can't push this. I can't push anything in a task in. I created as an empty vector, and it's going to stay an empty vector forever. But I can come in here and say mute in front of it, hit save, and now it's happy because I've told it that I'm allowed to mutate it. I'm now allowed to push in and use these mutating methods off of vectors. Okay, so we have a task vector with one task inside of it. Notice these warnings. Oh, go ahead.
One question.
Yeah.
So if I were to say let int x equals 0, I could not assign it a value unless I put mutable out there, right?
Right. So if I try to say 5 here, you'll notice that it's saying, hey, cannot assign twice to a mutable variable int x.
Right.
But if I allow this to be mutable, it now suddenly allows me to do that.
So it's pretty much what a constant would do in C++.
I believe so. I'm not used to C++, so
yeah, similar to the idea of having a constant.
yes. All right. Well, this is a little bit annoying to have to pass in, pass this in every time that I create a task. So I want to do what we call an implementation on task to give it a constructor, because there's no constructors by default in Rust structures. So if I do impl of task, I can now give it functions. I have to make these functions public explicitly because by default, every method in here is going to be private. So pub function, all functions start with the fn keyword. And I just call it new. That is the Rust community has sort of chosen this as the best practice for the constructor, but because there's no actual rule for this, you can call it whatever you want. And we're going to take in a name. The only times you have to type things in structs and in functions. Every other place, Rust is going to try to infer it. There's some times when you have to give other explicit typings, but 85% of the time this is going to work for you. So I don't know if you remember when I just hand coded the string, it came in as a ampersand str, ampersand being a reference, so reference to place in memory, and then we're going to do, I'm not even going to take in completed. That will be a default. This new is going to return a type, so I can give it a types task, and then I'm going to return a task. And we're going to say name is, and here's where I can say that string from name, and completed, I'm going to just say is false by default. Now, notice I don't have a semicolon here on this line, and it's not complaining to me. I could put in the return keyword, and if I did that and hit return, I have auto refactor, auto change my code on. It puts a semicolon there. That's because Rust includes if it's the last line of a block, if it doesn't have a semicolon, it auto returns that from the block. Just a little way to keep your code a little bit cleaner. It also makes it so that if you do a early return, it's very easy to see because there's that return keyword. So up here, we're going to push a new task in. So to call this method, it's sort of like a static method off of more of a an object-oriented programming language, I do that with : new, and then I have to just pass in what I want that to be. So in this case, we're going to put in a string, and we'll say give a meetup talk. Hit save, and we're all good to go. So we want to see all of our tasks. So there's a couple ways for us to print things out to the screen. Let's see. The pub can be left out if you're only going to use it in this file, right? Yes, I can leave the pub out if I leave these things in the main file. If you have these outside of the main file and you're using like a multi-file structure, you absolutely must have the pub in. So I will leave the pub in because that is what you need to do, and I don't want to like lead anybody the wrong direction. All right. Let's see. So if I want to print this out and display it to the screen, we have print line. Print line is the equivalent of like a console log in JavaScript. Notice here there's this exclamation point. Rust has normal functions, but they also have something called macros. I know that other languages have the idea of macros as well, and macros is a very complex topic in Rust. I'm not really going to get into it too much, besides there are macros that are predefined for us, like printline, that can kind of sort of make it look like it's breaking the rules of Rust. So in this case, I can pass in one thing only. So for example, I can pass in hello, semicolon, hit save. This compiles. Let's do a normal one. I can also use it sort of like the good old, what is it, like printf in C. So I can say my task name is that and has been completed, and then give this here. So we're going to say tasks position 0 dot name tasks position 0 dot completed. This looks like it breaks the rules of Rust because println allows me to pass in n number of things to it, but it's basically it's going to turn it into code at compile time based upon what I'm passing into it. So it's kind of like a dynamic function. These are obviously where I'm going to be passing in these variables, and they're going to be printed out here. So if I save this and we run this, here is my text. Task name is given meetup talk and has been completed. False. The task declaration would also need a pub. Oh yes, the task should need a pub. If I have this like in another file, I would need to like pub the task. So that's a good point. Okay, what if I want to print out just the entire task, and I want to like actually just display it? I could have another function here and call that and have it like print on its own. So let's actually maybe create a some kind of like a struct that wraps around all of our tasks, and it can handle some functions around it. So I'm gonna create another struct here, struct maybe to do. I'm gonna give task, and this will be a vector of task, and then we're gonna impl to do. So I like to create constructors for almost everything here. So pub function new, gonna return a to do, and we're gonna do to do task. There is a let's see, task back. So this is another macro that just makes it really easy to create a new vector. So instead of this vec new, I can just call this vec like this. And so now I can create a new vector with let to do equals to do new. And so now if I want to print out all of my tasks, I want to do something like to do dot, let's just say like print. Obviously that doesn't work yet. And it's going to yell at me saying, hey, no method name print there. So let's go and create one. Do pub function print. I'm not going to return anything. I'm just going to have this print directly out. So when you don't return anything, you don't have to return void or anything like that. You just leave out the arrow. Now, in order for this to work with dot here, that's different than this colon. I now have access to the contents of the instance of this struct. So I can get this through a reference to self, or if I need to, it could be a mutable reference to self. I don't need to mutate anything. I'm just going to print things out. So I want to loop through all of our to-do items and print them out. So we're going to do a for loop here. For task in self dot tasks. And you'll notice that this is very much like the Python style of looping through things. So I want to now do my print line. Let's give it a, like we can reserve this for when it's completed. We can actually figure out if it's completed or not. So we'll do let completed equals. So I'm going to do, if statements are really interesting. I could, let's do this like the traditional way we might do this first. I'm going to say that mute completed equals maybe like just a single character here. I'm going to say it's a space character. And then if task dot completed. So if that is true, then I want to say completed equals the character X. And then we end this if statement. We're going to have that be there. And then we're going to have the task here. So we'll do completed and then task.name. So we're going to loop through and print all these out. And we're running into an error here. If I actually try to run this, we get all this fun red stuff. Oftentimes, you might see Rust developers not even running the errors because you get these errors inside of like VS Code or Vim or your editor. But over, like when you run the code, you actually might get a little bit more information depending upon which editor you're using. So this is telling me that I cannot move out of self.task, which is behind a shared reference. So this is the famous borrow checker coming in and like yelling at us. Well, it's not really yelling at us. It's being a pair programmer to us. It's saying that what's happening is I'm giving ownership from the struct, from this vector, to the loop. And then as soon as this is closed, it gets dropped. And it's out of memory and it's gone. So something I didn't really mention before, in Rust, there's no garbage collection. It's all manual memory management, except unlike C or C++, we also don't need to call alloc or malloc or dealloc.
Yes.
It happens for us automatically as soon as a block ends. So this is telling me, hey, as soon as you're done with this, we've lost this. Free, thank you. What's going to happen is task is going to be deleted from memory. It's going to be freed from memory as soon as the first loop is done, except this loop might happen multiple times, so then I'm screwed. So what I need to do is I want to get just a reference to this. And now I don't need to take ownership of it, I borrow it. And so there's this idea of like borrowing things. And if you borrow something, you get like a shallow copy of it. Like it's just a pointer to a location in memory, as opposed to the full thing of memory. So now everything works.
Is there a reference count?
There are reference counter structures in Rust, but it doesn't do it automatically.
Right.
And that's where the old systems programming side of Rust comes in. It doesn't want to do things at runtime unless you explicitly tell it to do so. That way it runs much, much faster at runtime.
Right.
Okay, so we have print here. This should work. By the way, notice this. It's yelling at me because I don't need to have this be mutable because I'm not using that. So if I run this, well, nothing's going to happen really because I don't have anything in my vector. So let's move on to the next thing, which is I want to add a new task. So in to-do, let's create another function here. Add. I need to mutate self in this time. So we're going to do mute self, and then I want to take in the task that I want to add. So this will be a reference to a stir, or a string slice as it might also be called. And I'm not going to return anything. I'm now going to mutate by pushing into the task. So we're going to say self.tasks.push task new and pass in task. And there we go. So we can now add in a new task. So that's going to give a meetup talk. Save that. At this point in time, I can now run my code. It will run, and here is that display coming out. It's not completed, so I get a space. I want to do a little bit of a refactor before I move on to the next thing here. This in here, this if statement where I'm creating this completed out here. I don't have to do this. I can use the equivalent of a ternary statement to do this all in one go, except there are no ternary statements in Rust. Instead, if statements can be both just like a normal conditional, like we see in many other languages, but it can also be an expression. So if you're not used to more functional style programming, this could blow your mind. So I'm going to do equals, move if up here, if task.completed, and then I'm going to do just the X. Remember, if it's a block and there's no semicolon, it auto returns from that block. I do need to put a semicolon at the end of the statement because it's now an expression. I'm going to hit save, and now Rust is telling me, well, hey, what happens if it's an else? So Rust won't allow you to program something that could cause major problems later. It just will refuse to compile. So if it's an else, I want to return a space. And it kind of looks like a ternary statement because all on one line with the blocks here. You know, it kind of looks like it, but it really is just a normal if statement, except now it's an expression if. This works exactly the same way that it runs before. Nothing's changed running wise. It's just that we've now cleaned this up a little bit. Now, let's see. As a doer, I want to mark a task as completed. So if I want to mark something as completed, I need to be able to mutate it in some way. So let's go ahead and create a pub function. Maybe like we'll call this like complete. We'll obviously need to mute self for this. And we need to take in the index of what we want to mark as completed. There are many different number types in Rust. There's I types. So if I type I here, we see there's I128, I16. These are all the bits. So like 128-bit, there's 64-bit, all the way down to 8-bit integers. There's also U, so like U128, U8, in case you need those really big or really tiny numbers. Vectors index things through usize, which I've always found a little bit odd that it does, but I think somebody once explained it to me that this is how it's being done super deep low level in the maybe the kernel side or on the computer side, and Rust is basically matching that behind the scenes. So usize is basically whatever the computer generic U is. If you're not familiar with unsigned integers, that's what the U stands for. The sign I is for that negative in front of a number. Memory address space, thank you. Usize is like size T in C and C++. Okay, awesome.
Are they bitwise? Are they bit arrays as well in Rust?
Oh, bit arrays.
I mean, what I mean is, can you have can you have bit? Is there a bit data structure like can you address a bit?
Yes. You can. I've not done it. I've not needed to do it myself because I program almost always like at the very high level on Rust. So I've never run into that. But somebody in Twitch is saying bit type. I know it exists. I just can't point you exactly where it is, but I know the documentation will have something on it. I just don't know where to find it. Right. Oh, you think there isn't? Okay. I know there's like bit shifting, so you can definitely do bit shifting.
Okay, so so the unsigned can be used for doing that. Is that what you're referring to?
No, it's unsigned is mostly just it can't ever be negative. There's no negative on that. So if I start with 0 and I -1, I'm gonna get an underflow error.
Right.
Which kind of makes sense. Like an array can never have a negative idea,
Gotcha. Yeah.
Negative index to it. So Boolean types take the whole 8 bits, at least on your machine. Bool's called, you think? Yeah. And I know that there's tricks in Rust where you can do a lot of those type of things, but right. I don't know what they are. And then RJ Frame is saying there are crates for bit arrays, but it's not in the standard library. That's actually something I found out a lot, is that there's a lot of functionality in Rust that you'd think should be in standard, but you have to go to crate for it.
Right.
Somebody is suggesting bit vec crate is what you'd want for a bit array.
Okay.
All right, so if I want to complete this, well, we saw we can already get into the vector, so we're just going to say self dot tasks of position index, and I'm just going to say mark as complete. Maybe we could even toggle it. That doesn't exist yet, so I want to now come down to our task and create a pub function toggle. This is going to take in a mute self. And I'm not going to take anything in here. I'm just going to say self.completed equals not self.completed. And so that will just reverse whatever that is. So if we now come here, we say to do dot complete, give it an index of 0, semicolon that, and we print this out. We now get that nice X in front of here. So that marks this task as completed. Now, let's say I want to delete the task. I want to remove it from our vector. So there's a few different ways we can handle this. Vectors actually have a lot of really good vectors have good documentation. Let's actually go take a look at the documentation for Rust and find where it is for delete. So if I go to rustlang.org, learn, and then just down here, the standard library. This is one way to get to the documentation. This will get you to the latest version. So you notice that this is version 1.46. It's super easy on the web to accidentally go to the wrong version of whatever the documentation is. So Rust actually has an amazing way to get documentation that's guaranteed to be whatever version you're using locally. I can do rust up doc -- open. That wasn't right. I know rust up doc. There's no -- open. I don't know if you can see this, but it's now just file : //. This is just opening a local file in my browser. This is the Rust documentation on my system for whatever Rust version has been installed, which includes Rust by example, the Rust book. So let's go to where's the API documentation? Cargo book, not the edition. Oh, extensive documentation. I'm still on file : and now I'm guaranteed to be on whatever version of Rust I'm on. So if you're working on a project that has that's using nightly or is using some really old version of Rust, this is a way that you won't accidentally get let down by seeing things that you really want to use but don't exist yet. So if I want to search for vec, I'll just search for vec here, and I want standard vec. This is the contiguous global array. It sits on the heap memory-wise. Rust documentation will talk about explicit memory of where it is, and you can go as deep into that as you'd like. So I want, where's my vec? Here it is. So I actually wanted to go into standard vec. Documentation is a little bit funny to go through because there's multiple of the same type in here. But here's all the list of all the methods. For the most part, they make sense for what they look like. And then you can come around on the right and then see all the examples. All these example code is really interesting because they're guaranteed to work, even if this is just a crate and the documentation you're looking at, which, by the way, all public crates follow the same documentation path. If they have example code, Rust is going to guarantee that they actually work because Rust will run this example code as part of the compilation phase. And if it fails, it won't compile. So documentation, first-class citizen in Rust. So we want to probably remove here. Remove, we can see it takes in a mutable self and an index, which is a usize, and it removes and returns the element shifting all elements after it to the left. That sounds exactly what we want. If you want to actually see how it's implemented, you can go to the source code of Rust itself and take a look at it. It's a great way of like trying to understand how it actually works behind the scenes. This is the same way if you use a third-party library, exactly the same system. You'll be able to see their source code and how they implement. So back to our code. We're going to, let's see. We want to remove. So pub function delete self index usize self dot task dot remove index. Okay, and let's go ahead and delete 0. And so now when I print, there should be nothing out there. What is there left? So that's all these things in here. Now I want to show you something that's going to be a little bit more advanced. I want to show you how to implement what somebody else's a trait, as we call it. So a trait is kind of like an interface in an object-oriented programming language. So there is a trait called display. If I try to use this trick for printing, so let's come here to print. If I just say, I just want to print the full task. So I'm just going to say this and task like that. It's going to yell at me and say, task doesn't implement standard format display. I might be able to use this : for debug display. And so I could do this. But then if I do that, it yells at me and says, task doesn't implement debug. Well, I could, and you'll see this everywhere, is this hash open bracket, derive, hash open bracket derive debug. If I do that, this goes away. If I run this, it doesn't, oh wait, I deleted all the tests, so of course there's nothing to print out. Let's go ahead and not delete that right now. It prints out, but it prints out the actual name of the type because it's the debug printing. That's not exactly what I want. I want to have an override of how it displays on its own. So I don't want to use this : here. Well, there's no derive, which derive, by the way, just auto implements a trait. So it basically just implements debug for task for me. Thank you, Phil, for coming. Have a great time. I'm gonna have the video on later, so you can take a look at that. All right, so how am I gonna do this? I'm gonna say impl. So it starts the same way, and then I have to give it the name of our, well, not just the name, I have to give it the actual trait. So this comes from standard, FMT for format, and display for task. So if I hit save here, it starts yelling at me. It's yelling at me because not all the trait items are implemented. So this is the interface side of it. It's saying I must implement format and match whatever format is telling me. So I'm going to go ahead and type, what was it? It's FMT is the name of the function. So FMT. Because I'm using Rust Analyzer, it auto gives me this line here. I can hit return, and it just sets everything up for me, which is mostly what I want. It's not quite. I don't need this thing. All right, so cannot find formatter in this scope. I learned this just recently. I can do control dot, and VS Code will actually ask me, hey, do you want to import this? Yes, I want to import standard format formatter. It brings it up to the top, which is use standard format formatter. That's our import feature that imports this in. And this is going to return a, I want to actually return, I think, a standard format result like this. Is that right? It wants expected enum, standard. Oh no, just a standard result. Then never mind. You're just a standard result. So results are interesting. This is how we do error handling in Rust. There's no try or catch. Instead, this is saying, okay, I need type arguments here. So I need to give it a type of what these are. So I think I can say nothing. What do I need? If I just do this, it'll yell at me about what it should be. Form as incompatible type for trait. Okay, we can see here the error needs to be the standard format error. So I'm going to just copy that. That's my trick for figuring out what the types should be. That's what I thought too. Trugamo. Can't pronounce your name. Now it's yelling at me because I'm not returning this or this. So let's fix that. A result is an enumeration, essentially. It can be one or another value. It can be okay, or it can be an error. So I'm just going to go ahead and return okay with these parentheses. Parentheses is the equivalent of like just nothing, no op. There's no null in Rust, so it can't like return void or null.
Right.
Okay, so this is happy now, except if I print this out, it's not going to print anything. So there's another, there is another, what is it called? Macro for us to use here called write. And this is made specifically to work with this display here. So write, if I hover over this, will show me it wants to take in the writer, and then it's going to act exactly like the print line after that. So I'm going to hand it F and then the string. So I want that open bracket, close bracket, that completed thing, and then we're going to do dash, open and close bracket, and that's going to be the task itself. So we want that completed. So let's go ahead and do our if statement. So I'm going to do one final different way of figuring out how to create that completed here. We're going to say let completed equals, and this time I'm going to do something called a match off of self.completed. Match is sort of like, and I always forget the name of it because I never use them in the languages that I work with. It's sort of like a switch statement.
Switch.
Yeah, switch statement. Thank you. It's going to yell at me until I am matching all the possibilities for this. So it knows that it's a Boolean. So it knows that I'm going to have true, and this is a fat arrow in this case. So if it's true, I want to return the character space. And if it's false, I want to return the character X. And then here, we're going to pass in completed. And then I want to pass in the self.name. Now, write itself says that it returns a result. So if it's going to error, it's going to return an error. That error matches the error that we have here. If it returns okay, it's going to return this okay here, or something like that. So in Rust, lost my mouse. There it is. Match on this write, and if it's okay, underscore is like a catch-all. I don't really care about what it takes out. I want to now return, nothing. And if it's an error, extract the error, and then return error. Notice no semicolon in this match now, and I return this okay. And what are you yelling about? Actually have to return this as an okay, like that. And now we're happy. This was happening all over the place in code. So Rust decided, you know what? If this is happening so often and you're returning the same type, the same result type, I can abstract this out to question mark. So I can do question mark semicolon and then return okay. No match. And then this works. This is fine. Now, of course, this is returning a result. Okay is part of a result. I could just return the result of write. So let's go ahead and run this now. There's no errors anymore. So in Rust, generally speaking, if your code doesn't have any errors, it should compile and it should just work. And so here we go. Give a meetup talk. And I can now mark that as completed. I did mark it as completed. Did it not? Did it not complete it? It did not. What did I do wrong?
You have true and false are mixed up with the boolean physics.
Yes. So Rust likes to bill itself as if it compiles, your code will work and it will be right. Rust cannot and never will check yourself for logical errors. There's still the option for making these type of mistakes in Rust and having terrible errors that are really hard to find. That being said, testing exists in Rust. You can write tests. It's beyond the scope of this meetup talk. I would argue that it's maybe easier to find where these problems are, but don't let anybody in the Rust community try to tell you that Rust will prevent every error from ever happening to you again in the future. Which there are people in the Rust community out there who will say Rust is, the one language to defeat everything. You never need to learn language in your life. Accept it and move on. So I didn't want to go too deep into Rust. I just wanted to show you the very basic of the syntax for this. And then go into some resources for learning Rust. So I know there was a question early on that I didn't answer for what's a good Rust starting course. So I would recommend the book. There's also a tour of Rust. If you want the actual Rust course, I think that's the Rust Lings course that's off of the main website of Rust. And then after that, the Discord, which we gave the link out to that earlier in both chats. And so with that, I want to open up for questions. or no questions?
So I might have one. So here, if we wanted to make a CLI tool, what would you point us to so that we could complete tasks and all this actually in the command line?
Ooh, yeah. So if we go to creates.io, so there's probably a couple different ways to like go about it. It's like one of the biggest design questions would be, do you want it to like do an infinite loop so it's just constantly running and then you're interacting with it, or would it be an application that you like run one time, it like prints everything out, and then you can like run it again and pass it in standard in or arguments. Rust, for example, I can run just loop here, which is the equivalent of a while true. And that would just now live forever. And you not, like if I run this, just nothing happens because it's stuck in that infinite loop. And I think I can do Control Shift Escape, and we can take a look at what's the name of this? Can I even find it? I don't even see the application. Oh, no, that's my other one. It's not even taking up much CPU. Oh, here it is, To-Do app. It's taking up 5.9% CPU, even though it's on an infinite loop that's just running as fast as possible. So Rust is preventing that from taking like 100% of my CPU, which is, nice of it to do. That being said, there are some crates that a lot of people love for CLI applications. In fact, it's like one of the most popular keywords out there, and clap, I would say, is probably the most popular one. It's a command line argument parser. Does it have any examples? Yeah, so it'll help you like write out all the help stuff and auto handle all of those. Does that answer your question?
Yeah, cool, thanks. I think pointing to their crate repository, it's amazing how many things have already been made. So if you're thinking about this extra functionality, this crates.io, I think lib.rs is a mirror effectively of it. And you can find great stuff in here.
Absolutely. Chances are, if you want it to exist, most likely somebody has started writing it. How good that is up to debate because it's a new language. But for example, clap is, you can see how many times it's been downloaded at the bottom here. It is fairly popular.
So one question that I have is, I've seen talks that say there are mentors available for Rust, and I've been unable to find where these mentors actually are. Is there a place that is good to pair up with people that are working on actual products and start to learn Rust that way?
Absolutely. So one place that's always been told, for me, is this awesome Rust mentors location, where you can, I think, search for and try to find Rust mentors through any of the different locations here. So I'll link this. That being said, it can be maybe easier to like find somebody through one of the Discords. So I think we gave a link to the Discord, like the main Rust Discord out before. I'll do it again. Here, oh, I forgot to give this one to this other chat channel. There. So for example, for Discord, here is the Rust programming language. There's a beginners channel here. You can, like, it's very friendly. It's easy to ask questions here and get really great answers. You can ask questions, see who answers you, and then maybe private message them or just ask them like, hey, would you mind, like, helping me out or answering some other questions that I have for you. If you want to be a little bit more interactive, there is, and you like watching people live stream on Twitch, there is a Rustations team on Twitch. So you can watch Rust programmers live. For example, I'm here right now, so you can see I'm streaming this out. I'm gonna pause that. It's a little bit too. I forgot the name of that movie, but it's a little bit too crazy right now. But for example, Yasi is streaming. She writes a Rust error crate that's, I think, decently popular and very good with the puns. And so I know that she answers a lot of questions on her stream if you're willing to ask her. And so this is another great place to maybe go find there. Find people who are doing Rust and ask them questions. And if you're on the Denver Dev Slack, do I have that open? I do. Denver Dev Slack has the Rust channel. So let me see if I can find it really quickly. The Rust channel here is also filled with us awesome people who love to chat about Rust all day. So if you are on Denver Devs, highly recommend join this channel and then just chat about Rust. There's several people who are publishing crates or actually working with Rust in real life, or just learning it alongside of you. So you can find any number of like mentors or co-learnees. Any other questions?
So does this get used for doing things like systems level programming?
Yes. So while this is like a fairly high level like of programming, you can definitely write Rust in like to write operating systems. In fact, there is an operating system being written in Rust right now. There's probably actually several of them.
Right.
So that exists. There are people making video game engines, like not AAA yet, from what I understand, but like AA and indie game studios are starting to like look into Rust as for video games, and you need to pretty low level for that for like extreme speed and like calculating millions of bullets, per frame. There's also like Amazon is looking into it a lot for like some of their behind the scenes stuff going on. I know Apple has been hiring for doing a lot of like low level development with Rust. Mm-hmm. So definitely, you can definitely use it for systems level programming. And I would argue that professionally, that's where it's probably being used the most right now.
Right.
All right, any other questions? Going once. Going twice. Sold to all of you. All right, so next month, and for the Rust talk. Oh, by the way, when I get this talk uploaded to YouTube, I will share it here in the Rust meetup, and I'll also tweet it out to my Twitter, and I'll post it onto the Develop Denver meetup channel. So depending upon where you are, you can find it. So next time, we come to Rust Denver. Events. Andy Grove next month is going to be talking about data science with Rust. So that's going to be a really interesting talk. And I don't remember if Andy is doing Rust in production or not, but like at work or not. But it's going to be a great talk. So I hope to see you all there. It's going to be on Tuesday, October 20th at 6:30 p.m. And with that, I'm going to call it an end. Thank you, everybody, for coming, and I hope that you have a great rest of your night. And I'll see you next time.